Welcome to our deep dive, and this time we're taking a look at VMware Cloud Foundation. It looks like someone's getting ready for a big project.
Oh, yeah.
Yeah, setting up, configuring, maybe even managing a whole cloud foundation based on, well, this mountain of PDFs and manuals, I'd say.
It's ambitious.
It is. There's even stuff about stretching clusters and, hold on, AI and large language models too. Someone's going all in.
VMware Cloud Foundation can definitely handle it, that's for sure.
Before we get too deep, though, one thing really caught my eye. 2 whole blocks of private ASNs. Like, they never even touch the public internet. What's that about?
Yeah. It's basically like creating your own little internet just within your organization.
Mm-hmm.
Those ASNs, they're autonomous system numbers. They handle routing internally, keeps everything organized, secure, all behind the scenes.
So no peeking for the outside world.
Nope. Like a secret handshake, only your organization knows it.
I like that analogy. But okay, let's back up a sec. For folks who might be new to this whole cloud foundation thing, what is it in plain English?
Imagine a software-defined data center,
Wow.
but it's like a prefab house kit. All the parts are there.
Okay.
Compute, storage, networking, cloud management, all packaged up, ready to assemble. That's Cloud Foundation. The blueprint, 80 the tools, all in one.
So it's not just about having the right parts, it's having the system to put them together right.
Exactly. And it's all automated. Deploying, configuring, vSphere for compute, vSAN for storage, NSX for networking,
Yeah.
VMware Area Suite to manage it all.
This thing even deploys VMware Area Suite Lifecycle. That sounds powerful, like really powerful.
It is. Think of Lifecycle as your dedicated project manager, overseeing the entire Cloud Foundation from start to finish.
Nice. Now, these docs keep mentioning workload domains. What are those, and like, how do they fit in?
Think of them like rooms in your Cloud Foundation house.
Okay.
You got the management domain, that's the control center, and then VI workload domains. Those are where the action happens. Your apps and services run there.
Gotcha. And why separate them? What's the advantage?
Security and stability, mainly. Keep the management stuff isolated from the workloads, so it's more secure. And even if one workload domain goes down...
The whole house doesn't go dark.
Exactly.
Yeah.
It's like having separate circuit breakers for each room.
Smart. Okay, so how many rooms can I have? Workload domains, I mean.
Up to 14 VI workload domains per instance. Plenty of space to grow.
Now, something else keeps popping up. Day 0 and this management domain. What's so special about Day 0?
Day 0 is like the groundbreaking ceremony for your Cloud Foundation. It's when you set up that management domain, lay the foundation for everything else, deploy the VMware Cloud Builder appliance, prep the ESXi hosts, get the networking sorted, vSAN storage all configured.
So if you mess up Day 0...
Yeah, it can have some serious consequences down the line.
This document actually says messing with things outside of SDDC Manager can cause instabilities. That's good to know before you break something.
SDDC Manager is your primary interface for managing everything. Stick with that and you'll be all right.
SDDC Manager is like the architect then.
Good way to put it. It handles all the interactions between the different components.
Yeah.
Keeps things running smoothly.
All right, got my architect, Day 0 is planned. But what about permits? How does licensing work with this whole Cloud Foundation thing?
You got 2 main options. vSphere Foundation, that's like the basic package.
No.
And then there's VMware Cloud Foundation itself, the all-inclusive deluxe.
So one's buying the tool separately, the other's the whole toolkit.
Exactly. Cloud Foundation bundles it all. vSphere vSAN, NSX, VMware Area Suite, the works.
That's convenient, but I noticed something about separate keys, even with the deluxe package.
Yeah, some components still need their own licenses. It's not perfect, but hey, it's like having a master key, right?
With a few extra locks here and there.
Right.
Okay, so foundation's laid, we've got our tools. Now what about storage? What are my options for keeping all this data in my shiny new Cloud Foundation?
For your VI workload domains, you've actually got quite a few choices. You can go with VN, NFS, VMFS on Fiber Channel, or even vSphere virtual volumes.
Hold on, it says here, Cloud Foundation always puts managed VMs in the first cluster you make. Is that something to watch out for?
It can be, yeah.
Yeah.
You got to plan those clusters carefully. Don't want to end up with all your management VMs crammed in one place. Could cause bottlenecks later on.
Makes sense. So you got to make sure that first cluster can handle the load. Speaking of vSAN, which seems to be the popular choice, the docs mention this policy-driven, object-based storage thing. What's that all about?
It's like, imagine having a personal organizer, but for your data. You set these policies, they dictate how everything's stored and protected. RAID levels, failures to tolerate, even data locality. You're not just dumping data in a bin, you're placing it strategically.
So different levels of service for different data.
Exactly. And vSAN handles the complex stuff behind the scenes based on your policies.
Okay, that's pretty cool. But what about data protection? How does vSAN make sure nothing gets lost?
Oh, it's got a whole arsenal of features for that. RAID 5 or RAID 6 erasure coding for distributed parity, like having backup spread across multiple drives.
And mirroring.
Of course, replicates your data across multiple hosts, even sites. So even if a whole site goes down,
your data's still safe.
You got it. Minimizing downtime. That's what VSAW is all about.
I like the sound of that. There's also this deduplication and compression. It's like squeezing more into the same space, right?
Exactly. Gets rid of redundant data blocks, compresses the rest, like packing your suitcase efficiently, you know?
Love that analogy. But hold on, this says it needs all flash storage for that. Why is that?
To really take advantage of those features, you need the speed of all flash. Performance boost, big time.
Makes sense. There's also a note here, compatible with data store encryption, but not VM encryption. What's the deal there?
It's because of how deduplication and compression work. They need to see those data patterns. But with VM-level encryption...
the patterns get hidden.
Exactly. So if you need VM encryption, you might not see those same storage savings. Trade-offs, right?
Right. Okay, so vSAN's pretty powerful, but then there's this vSAN ISA. Sounds like the new kid on the block. What makes it different?
Think of vSAN ISA as like the next-gen sports car of vSAN. It's the express storage architecture, all about NVMe, super high performance.
But this says it's mainly for new deployments. Why is that?
It's optimized for those greenfield environments. Brand new setup, latest NVMe drives, all that.
So if I'm building a brand new high-performance setup,
vSAN ISA is worth a serious look, especially for demanding stuff like databases, big data, even AI and machine learning.
Speaking of AI, there's a note here. Not all vSAN ISA features work with Cloud Foundation yet. Anything in there that'd be a deal breaker?
Well, Crust vSAN or vSAN ISA isn't supported yet, so if you need that, might have to consider alternatives. For now.
Good to know. Now let's talk about something you mentioned earlier, stretching clusters. It sounds intense, but is this all about disaster recovery?
It is, yeah. Imagine you're extending a vSAN cluster across multiple sites.
Mirroring everything.
Pretty much. So if one site goes down, the other takes over seamlessly. Minimal downtime, no data loss.
Okay, but that sounds complex. What do I need to, watch out for?
You need a strong network connection between the sites, for one. Low latency is key. And you need specific network pools for each availability zone.
Anything else?
Enough IP addresses on the overlay, for sure. And of course, compatible hardware and software at both sites. You know, the basics.
Right, right. Now, the docs mention a witness appliance. What's that all about?
The witness. It's like, think of it as the tiebreaker. If there's a network issue between the sites.
Okay.
As a small VM, helps keep the cluster consistent, prevents data corruption. Very important for stretched clusters.
And are there sizing guidelines for that? Where would I find those?
The VMware Cloud Foundation docs have all the details on sizing the witness appliance. Make sure you get that right, based on your cluster size and how active it is.
Okay, I'll check that out. Now, this next part blew me away. You're looking at running AI workloads on this thing. Seriously.
Yeah, seriously. VMware Cloud Foundation can handle it, especially those AI workloads that use large language models.
LLMs, right. Those are the brains behind ChatGPT and all those AI chatbots everyone's talking about.
That's them. Complex neural networks, trained on tons of data, text, code, all that.
And this document says NVIDIA GPUs are key for this. Is that why it also talks about NVIDIA vGPU Manager and NVLink?
It is, yeah. Those NVIDIA technologies, they make AI workloads possible within VMware Cloud Foundation.
Okay, so break it down for me. How do they actually enable this?
Well, first, you need those GPU-enabled ESXi hosts. That's the muscle. Then vGPU Manager comes in. It lets you share those GPUs across multiple VMs, like slicing a big pie into smaller pieces.
Makes those expensive GPUs go further.
Exactly. Especially helpful for AI workloads that don't need a full GPU all the time.
Smart. And NVLink, that's the speed thing, right?
Yep, it's like a superhighway connecting the GPUs. Super fast, low latency, perfect for all that data crunching AI needs.
Okay, I think I'm starting to get it. So we've got the hardware, the sharing, the speed. But what about the so what? What are some of the coolest things you've seen people do with AI on Cloud Foundation?
Well, healthcare has been doing some amazing things. Analyzing medical images, helping with diagnoses.
Oh, wow.
Yeah, imagine a hospital using Cloud Foundation to run an AI system that can detect early signs of cancer just from mammograms.
That's incredible.
It is. And Cloud Foundation is the platform that makes it all possible.
Okay, this is getting me really excited. But honestly, it all sounds so complex. Do I need a PhD to manage this thing?
It helps to have some experience with VMware and cloud stuff, sure. But they've got great documentation, training, and their support team is really helpful.
Okay, that's good to know. Now, I saw something called the SOS utility mentioned. What's that?
Think of it as your Swiss Army knife for troubleshooting, built right into SDDC Manager. It can
Yeah.
run health checks, collect logs, even validate passwords. Pretty handy if something goes wrong.
So if I'm in trouble, SOS is my go-to.
Yep. But remember, it needs root access,
Mm.
so got to be careful with it.
Powerful tools, powerful responsibility. Got it. Well, I think that's a good spot to pause for now. We've covered a lot, too. From the basics of Cloud Foundation to storage, networking, even dipping our toes into AI.
And we're just getting started.
I know, right? So much more to explore. Next time, we'll dive into managing and securing your Cloud Foundation lifecycle stuff, some more networking fun.
It's gonna be good.
Until then, keep those cloud dreams alive.
See you anytime. Welcome back to our Cloud Foundation deep dive. Last time we went through the basics, workload domains, storage choices, even touched on AI workloads. It's amazing what this platform can do.
Seriously, setting up that management domain, deploying via SAN, the stretched clusters for disaster recovery, my mind was blown.
Yeah, it's pretty powerful stuff. But there's still so much more to uncover. Today, let's dive into managing and securing your Cloud Foundation, and we'll take a look at lifecycle management, upgrades, some cool networking concepts too.
Sounds like a plan. I'm
Yep.
ready when you are.
All right, let's jump in. One thing that stood out to me in these materials was how you safeguard those Cloud Foundation components within vSphere. Like, what's the strategy there?
Yeah, that caught my eye too. It's like they're saying to treat the Cloud Foundation parts differently, even within vSphere.
Exactly. You see, vSphere, it's the foundation of the whole platform, right?
Okay.
But you got to make sure there are no conflicts between vSphere configurations and SDDC Manager.
Right, SDDC Manager, that's our command center for Cloud Foundation.
Right. So if you've got vSphere admins running around, they need to be extra careful not to mess with anything related to Cloud Foundation.
So, like, restrict their access, make sure they only touch what they absolutely need to.
Exactly. Education is key too.
Yeah.
Make sure they understand that making changes outside of SDDC Manager, well, it can break things. It's like a look but don't touch policy for anything Cloud Foundation related.
Makes sense. Keep that Cloud Foundation stuff in its own protected zone. Speaking of protection, let's talk passwords. The EDUN VCF DCM 5.2-LEC-IE.pdf document really stresses regular password rotations. How does Cloud Foundation handle all that?
SDDC Manager's got your back. It's like a central vault for all your passwords.
Okay.
You update passwords for accounts that are, synced with SDDC Manager. You can even remediate passwords to make sure everything matches up between SDDC Manager and the actual entity.
So I don't have to go into each individual component and update passwords separately?
Yep. SDDC Manager streamlines all of that, keeps things consistent, reduces the risk of having mismatched passwords across your whole Cloud Foundation.
That's a huge GE time saver and a relief.
Hmm.
Now, while we're talking management, I came across Power CLI. What is that exactly, and what's its role in the Cloud Foundation world?
Power CLI. Think of it as a secret language for talking directly to your VMware environment, Cloud Foundation included, of course.
Secret language, huh?
Yeah. It's a command line tool based on PowerShell. And it's got specific commands just for managing and automating tasks.
So if I'm a PowerShell whiz, I can use Power CLI to basically automate everything and control my Cloud Foundation from the command line.
You got it. It's all about flexibility and control. Deploying VMs, configuring networking, managing vSAN. You name it, you could probably automate it with Power CLI.
That's awesome. But the documents also mention SDDC Manager having its own set of APIs. What's the deal with those? How are they different from Power CLI?
Well, imagine you want to connect your Cloud Foundation to other systems, right? Or build your own custom tools to manage it. The SDDC Manager APIs, they give you that backend for programmatic control.
So it's like a back door into my Cloud Foundation, but for applications, not hackers, hopefully.
Exactly. APIs open up a ton of possibilities. Automation, integration, customization. You're not limited to just what VMware provides out of the box.
Okay, that makes sense. It's like Cloud Foundation is a platform, not just a product. Now let's dig into networking for a bit. We know Cloud Foundation depends on NSX, but can you explain how it actually works within a Cloud Foundation?
Think of NSX as the nervous system of your Cloud Foundation.
Okay.
It's the software-defined networking layer that connects everything. Your workloads, virtual networks, security policies. It even extends your network out to public clouds.
So NSX is the glue that holds it all together.
You got it. It's the fabric that lets everything communicate.
Now, what about this NSX Edge thing that keeps popping up? What is that, and what is a DO?
Okay, picture NSX Edge as a virtual security guard, standing right at the entrance to your cloud foundation.
I like it.
It's a virtual appliance, provides all its network edge services, NAT, firewalling, VPN connections, load balancing, all the essentials.
So it's the bouncer making sure only the right traffic gets in.
Yep. And it's also responsible for connecting your cloud foundation to any external networks. Keeps things secure.
Multitasking security guard. Nice. Does Cloud Foundation automatically set all this up, or do I have to manually deploy NSX Edge?
It's all automatic. When you set up the management domain, Cloud Foundation takes care of deploying an NSX Edge cluster for you. Usually 2 or more nodes for redundancy, just in case.
That's good to know. So I don't have to worry about it. Now, there's also this bare metal NSX Edge. What's the difference between that and the regular kind?
Think of it like this. Regular NSX Edge. It's running as a virtual appliance on top of your ESXi hosts, like a guest in a hotel.
Okay, so bare metal is like...
Bare metal. It's like having its own dedicated apartment running directly on physical hardware.
So it's all about performance and control. When would I actually choose to use bare metal?
If you need the absolute best performance, lowest latency. Bare metal is the way to go. Think demanding telco applications or any other latency-sensitive workloads.
Got it. So it's the high-performance option. Okay, now let's talk about connecting my cloud foundation to the outside world. The materials mention both VLAN and overlay transport zones. What are those, and what's the difference?
Imagine this. VLAN transport zones, they're like those traditional roads. They connect your cloud foundation to the existing physical networks that use VLANs.
Okay, that makes sense. And overlay.
Overlay transport zones, they're like building a whole network of sky bridges above those existing roads, using a technology called VXLAN.
So I can bypass all the traffic down below?
Exactly. More flexibility, more scalability. You're not limited by the physical infrastructure.
Sounds pretty cool. So how do I choose? When would I go for VLAN, and when would I use overlay?
If you've got an existing network and it's heavily reliant on VLANs, sticking with VLAN transport zones is probably the easiest path. But if you're starting fresh or need more agility, overlay is the way to go.
Makes sense. Now, what about these uplink profiles I keep seeing? What are they, and how do they relate to these transport zones?
Think of uplink profiles as traffic cops. They direct traffic between your ESXi hosts and the physical network. They decide which physical NICs on your hosts get used for specific transport zones.
So I can use them to control, say, which NICs handle VLAN traffic versus VXLAN traffic.
Exactly. You get really granular control over how your hosts connect to the network. Create different profiles for different types of traffic, workloads. It's very flexible.
I like it. NSX gives you so much control over your network. Now, I saw something about traffic separation within workload domains. What's that all about, and why would I want to do that?
Imagine you've got a highway, right? And you can dedicate specific lanes for different types of vehicles. Cars, trucks, motorcycles.
So it's like organizing the traffic.
Exactly. Within a workload domain, you can separate different types of traffic. And each type gets its own dedicated physical NICs on your hosts.
So I could have one set of NICs just for vMotion traffic, another for vSAN, and another for my applications. What's the advantage of that?
It's all about performance and resilience. You're making sure that critical traffic, like vMotion or vSAN, doesn't have to compete with your application traffic for bandwidth.
So no traffic jams.
Exactly. You're optimizing performance for each type of workload.
That's awesome. Now, how does Cloud Foundation decide which physical NICs to use for which traffic when I deploy a workload domain?
That's where network profiles come in. You've got 2 options. The default profile, which uses a predefined configuration, or you can go with a custom profile if you want more control.
So default is the standard route, and custom lets me create my own path.
Exactly. With the custom profile, you can manually specify which NICs handle which type of traffic. You can even create new vSphere distributed switches if you need to.
Wow, that's a lot of control. Now, I saw something about using JSON configuration files for multi-NIC setups. Is that still a thing?
Yeah, so before Cloud Foundation 5.1, if you wanted to use a custom profile with more than 2 NICs, you had to get a little technical. You had to use the SDDC Manager API and provide a JSON configuration file with all the details. It was a bit of a pain.
That does not sound fun.
It wasn't. But thankfully, from version 5.1 onwards, they made it much easier. You can configure those multi-NIC setups right in the SDDC Manager UI, even with custom profiles.
That's a relief. Much more user-friendly. Okay, so let's say my workload domain's all set up and running smoothly, but then I need to add more hosts to it. How do I do that?
Adding hosts is pretty straightforward. In SDDC Manager, you just select the workload domain you want to expand and then hit that Add Cluster option.
Easy enough. But are there any gotchas? Anything I need to be careful about when I'm adding these new hosts?
The main thing is consistency. Make sure the new hosts have the same storage type as the existing ones in the workload domain, and make sure they're configured with the correct network pool settings.
So no mixing and matching different types of hosts?
Not really, no. You want to keep things consistent to avoid any potential headaches down the line.
Gotcha. Consistency is key. Now, the documents have some interesting diagrams showing how NSX Manager instances can be shared or dedicated across workload domains. Can you explain that a bit?
Sure. You've got some flexibility in how you deploy and manage those NSX Manager instances. You can have a single NSX Manager handling multiple workload domains.
So I don't need a separate NSX Manager for each workload domain?
Nope. It can simplify things and save resources. And when it comes to NSX Edge nodes, all the vSphere workload domains can share the ones deployed in the management domain. If you need even more horsepower, you can use SDDC Manager to deploy additional NSX Edge clusters within specific vSphere workload domains.
So it's all about sharing resources and being efficient.
Exactly. Cloud Foundation gives you the tools to optimize your NSX infrastructure.
That's awesome. Now, when I'm designing these workload domains, are there any specific considerations I should keep in mind when it comes to storage?
Absolutely. One key decision is whether to use a vSAN data store or a vSAN cluster as your principal storage method.
What's the difference? When would I choose one over the other?
Well, a vSAN data store is like the basic option. Simple to set up, easy to get started with. A vSAN cluster, though, that's where you get more granular control over your storage.
Oh?
You can define different fault tolerance levels, create storage policies, even set up those stretched clusters for disaster recovery that we talked about earlier.
So if I need more bells and whistles, more control over my storage, I'd go with a vSAN cluster.
Exactly.
Yeah.
It's the more advanced option.
Okay, that makes sense. Now let's talk about vSphere Lifecycle Manager. I know it's a powerful tool for managing ESXi hosts, but how does it work within Cloud Foundation?
Think of vSphere Lifecycle Manager as a personal assistant for your ESXi hosts. It's built right into Cloud Foundation, and it takes care of everything. Updates, patches, even firmware upgrades.
Wow, so I don't have to manually update each host anymore?
Nope. Lifecycle Manager automates the whole process, keeps your hosts up to date, patched, and running smoothly.
That's a dream come true. But I noticed Lifecycle Manager uses images for managing hosts. What are those exactly, and why are they important?
Think of an image as a blueprint for your ESXi hosts. It captures the desired state of your host.
Okay, so it's like a snapshot.
Yeah, kind of. It includes the operating system, all the components, drivers, firmware, everything you need.
So instead of dealing with individual updates and packages, I can just manage this one image that represents the perfect configuration for my hosts.
Exactly. Simplifies things a lot. You can create different images for different types of hosts, workloads, and then easily update and deploy them whenever you need to.
I love it. So vSphere Lifecycle Manager handles the ESXi side of things, but what about NSX? How do I upgrade and manage those components within Cloud Foundation?
For NSX, you've got the NSX Upgrade Coordinator. It works hand in hand with vSphere Lifecycle Manager to make sure everything gets upgraded smoothly and in the right order.
So it's a coordinated dance to keep everything in sync.
You got it.
Now, when it comes to upgrading Cloud Foundation itself, I see mentions of both online and offline depots. What are those all about, and when would I choose one over the other?
By default, Cloud Foundation connects to an online depot hosted by VMware. That's where it downloads all the upgrade bundles and patches. But if you're working in an offline environment or have limited internet access...
Is an offline option?
Yep. You can use an offline depot. VMware provides a tool called the Offline Bundle Transfer Utility. It lets you download all the updates to a local web server.
So it's like having a local copy of everything I need.
Exactly. Then you just point SDDC Manager to that local web server, and you're good to go.
Awesome. That's a lifesaver for those offline setups. What about the actual process of upgrading a workload domain? What are the steps involved?
SDDC Manager usually walks you through the whole process. You export the desired Lifecycle Manager image from vCenter, then import it into Cloud Foundation. Then you configure the upgrade settings and kick off the process.
Sounds simple enough, but I noticed some details about customizing the BOM during upgrades. What is BOM customization, and why would I want to do that?
The BOM, it stands for Bill of Materials. It's basically a list of all the software components that make up Cloud Foundation.
Gotcha. So what can I customize?
Well, in the past, upgrades were tied to specific BOM releases. You got what you got. But from version 5.2 onwards, you can actually customize the BOM during upgrades.
So like pick and choose which components I want to upgrade.
Exactly. You can choose specific versions, patches. It gives you a lot more control over the process. You can even include asynchronous patches that were released after the main BOM.
Wow, that's a lot of flexibility. Now, Cloud Foundation is all about automation, right? But what about the role of VMware Area Suite, especially VMware Area Suite Lifecycle? How does that fit into the picture?
Think of Area Suite Lifecycle as the conductor of an orchestra.
Okay.
It integrates with Cloud Foundation and helps you manage the entire lifecycle of everything. Your Cloud Foundation, other VMware products, you can deploy, configure, monitor, upgrade, all from one place.
So it's like mission control for my entire VMware world.
That's a great way to put it. It really simplifies and streamlines everything.
Okay, that sounds amazing. And I know that Cloud Foundation can automatically deploy Area Suite Lifecycle. Can you walk me through that process?
Sure. First things first, you need to plan and prep your environment. Use the planning and preparation workbook and check out the Cloud Foundation docs. Then you got to deploy an NSX Edge cluster. It's needed for deploying any of the Area Suite products. But don't worry, SDDC Manager makes this easy. Once the NSX Edge cluster is up and running, you're ready to deploy Area Suite Lifecycle.
Okay, so a few steps, but it sounds pretty automated.
It is.
And once Area Suite Lifecycle is up and running, what can I do with it?
Oh, you can manage a ton of VMware products and services. You can deploy and manage Workspace ONE Access, which provides secure, role-based access to all your Area Suite goodies. And of course, you can use it to manage the entire suite of Area products, Area Automation, Area Operations, logging, networking, you name it.
So it's really a one-stop shop for managing my entire VMware ecosystem.
Exactly.
Awesome. What about deploying Workspace ONE Access on Cloud Foundation? What are the advantages of doing that?
Think of Workspace ONE Access as a security checkpoint for your Area Suite products.
Okay.
It handles authentication, authorization, makes sure only the right people can access your sensitive cloud management tools.
So like a security guard at the entrance?
Exactly. Adds an extra layer of protection.
Love it. Now, let's talk about certificates. I know Cloud Foundation has its own system for managing certificates. Why is that so important?
Certificates are like digital passports. They establish trust and security within your Cloud Foundation environment.
Okay, so they verify identities.
Right. They're used for authenticating users, services, encrypting communications. They keep things running smoothly and securely.
What happens if my certificates expire or someone manages to, like, compromise them?
Oh, that's bad news. It could disrupt services, create security holes. That's why Cloud Foundation has its own system for managing certificates. You can use it to generate new ones, replace expired ones, even integrate with those external certificate authorities.
So I can handle everything right within Cloud Foundation.
You got it. It's all about keeping those certificates up to date and secure.
Okay, that makes sense. But what about the actual workflows for installing certificates? I see mentions of integrated CAs and external CAs.
Cloud Foundation supports two main workflows. If you've got a supported integrated CA, you can use that to generate and install certificates right within SDDC Manager.
And what if I'm using an external CA, like Let's Encrypt, for example?
For external CAs, there's a bit of back and forth. You generate a certificate signing request, or CSR, within SDDC Manager. Then you get it signed by your external CA and upload the signed certificate back into SDDC Manager.
So SDDC Manager provides the tools, but the external CA is the one who actually signs off on the certificate.
Exactly. It's a collaboration.
Got it. Now, let's circle back to upgrades for a minute. We talked about vSphere Lifecycle Manager, but are there any specific considerations I should keep in mind when upgrading workload domains?
One thing to watch out for is the order in which you upgrade components.
So there's a specific sequence I need to follow.
There is. Cloud Foundation has a specific order to make sure everything goes smoothly.
What's the general rule of thumb?
You usually upgrade SDDC Manager and the Cloud Foundation services first. Then you do Area Suite Lifecycle, Area Suite products, and finally, Workspace ONE Access.
Okay, good to know. Anything special about upgrading NSX?
You use the same NSX bundle to upgrade both the management domain and the VI workload domains. Make sure to run the pre-check before you start. just to catch any potential issues. And just like other upgrades, you can either start it right away or schedule it for later.
Okay, I'll make a note of that. Now let's shift gears and talk about security, which is always a top priority. We've touched on workspace, one access, certificate management. But what are some other security best practices I should keep in mind when I'm working with Cloud Foundation?
Security is paramount. Cloud Foundation has a ton of features and best practices built in. One key principle is applying the principle of least privilege. Have you heard of that one?
Yeah, I think so. Can you remind me what it means?
It basically means you should only grant users and services the bare minimum access they need to do their jobs.
So don't give anyone more access than they absolutely need.
Exactly. It's a fundamental security principle. Right. It minimizes the damage if an account gets compromised or if you've got a malicious insider.
Makes sense. So how do I put this principle into practice within Cloud Foundation?
vCenter roles. vCenter roles, they define what permissions users and groups have within your vSphere environment. You can create your own custom roles or use the predefined ones. It's all about granularity.
So I could create a role for, say, a network admin that gives them access to all the network settings, but not the storage settings.
Exactly. By carefully assigning those roles, you're enforcing the principle of least privilege and making your Cloud Foundation much more secure.
Okay, that's a great tip. Are there any guidelines for assigning these roles effectively? Any pitfalls to avoid?
Definitely. First of all, avoid giving out full vCenter administrative rights, unless it's absolutely necessary. It's a lot of power, and you don't want to give it to just anyone. And avoid assigning those vCenter roles to generic groups, like domain admins. Create specific groups for specific vSphere management functions.
So the more specific I can be, the better.
Exactly. It's all about granularity and control.
Okay, that's helpful. Now, the documentation also mentions something called propagation when you're assigning permissions. What is that, and why is it important?
Imagine you've got a folder, right? And you set some rules for that folder. Propagation controls whether those rules automatically apply to everything you put inside that folder.
So it's about inheritance.
Exactly. It controls how permissions are inherited within vCenter. So if you enable propagation, any new objects you create within a parent object will automatically inherit the permissions of that parent object.
So if I create a new VM within a folder that has certain permissions, that VM will automatically inherit those permissions.
You got it. It makes managing permissions much easier, and it makes sure that everything has the right level of access control.
That makes a lot of sense. Now let's talk about securing the ESXi hosts themselves. There are all sorts of ways to access and manage them. Are there any security risks I should be aware of?
Oh, definitely. It's crucial to carefully control who has access to your ESXi hosts and how they access them.
Okay, so what are some best practices for securing ESXi host access?
Whenever possible, use the vSphere client to connect to vCenter and manage your hosts centrally. That gives you a single point of control and it's much more secure.
So avoid direct access to the hosts.
If you can, yes. Don't use the VMware host client or the DCUI unless you absolutely have to.
So vCenter is my security command center for managing those ESXi hosts.
You got it. It's the safest way to do it.
Okay, that makes sense. What about SSH and the ESXi shell? Should I disable those completely?
Generally speaking, yeah. Keep SSH and the ESXi shell deactivated, unless you specifically need them for troubleshooting. And if you do need to use SSH, consider running it under a sandbox domain.
A sandbox domain? What's that?
It's a limited, restricted shell environment. It's like putting SSH on a leash.
Okay, so it limits the potential damage if someone compromises the SSH session.
Exactly. It's a smart way to add an extra layer of security.
Love it. Now, I saw something in the documentation about lockdown modes for ESXi hosts. Can you explain what those are and how they work?
Lockdown modes are like putting your ESXi hosts on high alert.
Okay.
There are two modes, normal and strict. Normal lockdown restricts access to the DCUI and the ESXi shell. Only authorized users can get in. Strict lockdown is even more secure.
How so?
It locks down the host to only the VPEX user account. That's the account vCenter server uses.
So basically, if I enable strict lockdown mode, the only way to manage that host is through vCenter?
You got it. It's super secure, but it also means you can't manage the host directly.
Good to know. Now let's talk firewalls, which are a must-have for any security strategy. How do they fit into the Cloud Foundation world?
You've got options. Cloud Foundation supports both physical firewalls and virtual firewalls.
Yeah.
So you can have a layered approach to security.
Okay, so I can use a combination of hardware and software firewalls.
Absolutely. Physical firewalls, they usually protect the perimeter of your network. While virtual firewalls, those are deployed within your cloud foundation. They give you more granular control over traffic between workload domains or even individual VMs.
So it's a flexible setup. How do I decide where to put those firewalls within my cloud foundation environment?
It really depends on your security needs and how your network is set up. A common approach is to use physical firewalls at the edge and then virtual firewalls inside your cloud foundation. That way you can segment traffic and enforce more specific security policies.
Okay, that makes sense. Are there any specific firewall configurations I should be aware of when I'm deploying Cloud Foundation? Any gotchas?
Make sure you've got the right ports open. For all the Cloud Foundation services to work correctly, vMotion, VSAN, NSX communication, they all need specific ports open.
Right, so it's a balancing act, right? I need to allow the good traffic in, but keep the bad traffic out.
Exactly. Firewall configuration is a key part of security.
Okay, I'll double check my firewall settings. Now, we've talked about firewalls, access control, but what about more advanced security techniques like microsegmentation? Is that something I can do with Cloud Foundation?
Oh, yeah, definitely. Cloud Foundation uses NSX to provide some pretty powerful microsegmentation capabilities.
So it's not just about having a big firewall at the edge. I can actually create granular security boundaries within my Cloud Foundation.
You got it. It's like having a security checkpoint at every single door within your Cloud Foundation.
That's amazing. How do I actually implement microsegmentation? What tools do I use?
NSX security groups and distributed firewalls are your best friends here. Security groups let you group VMs based on their function, and distributed firewalls let you define rules for how those groups can talk to each other.
So I could have a security group for my web servers, another for my databases, and then use distributed firewalls to control the traffic between them.
Exactly. You get really fine-grained control over everything. It's a great way to enhance security and minimize the impact of any potential breaches.
Okay, that's really impressive. Now let's switch gears for a bit and talk about compliance. I know security and compliance go hand in hand, but what are some specific compliance considerations I should keep in mind when I'm deploying Cloud Foundation?
VMware Cloud Foundation is designed with compliance in mind. It can help you meet a ton of different compliance requirements.
Like what?
Well, you've got industry-specific standards like HIPAA for healthcare, PCI DSS for payment cards, and then there are the general data protection regulations like GDPR.
So Cloud Foundation has features that make it easier to comply with all of these regulations.
It does. You've got tools for data encryption, access control, auditing, logging, all the essentials for compliance.
That's good to know. Are there any specific compliance considerations I should be thinking about early on, like during the design phase of my deployment?
Definitely. Identify all the compliance requirements that apply to you right from the start, and make sure you integrate them into your design. Data residency requirements, encryption standards, access control policies. Think about all of that early on.
So compliance shouldn't be an afterthought.
Definitely not. Trying to add compliance after you've already built everything is a nightmare.
Okay, I'll keep that in mind. Now, I know VMware has a ton of resources and documentation on compliance. Where's a good place to start?
Their website has a whole section dedicated to compliance. You'll find details about certifications, all sorts of resources, guides, white papers, everything you need.
Perfect. Now, we've talked about securing the ESXi hosts, but what about the VMs themselves? How do we make sure they're secure within Cloud Foundation?
Securing your VMs is just as important as securing the underlying infrastructure. It's the same basic principles, really.
So, keep the operating systems patched, use strong passwords, install antivirus software, all the usual stuff.
Exactly. Treat your VMs just like you would any other server.
Okay, that makes sense. But does Cloud Foundation offer any additional tools or features that can help me secure my VMs?
It does. You can use vCenter roles to control who can access the VM consoles. And you can deactivate any unnecessary hardware devices within the VMs, like CD-ROM drives or floppy drives. It's all about reducing the attack surface.
So I'm minimizing the ways someone could potentially compromise a VM.
Exactly. Every little bit helps.
Okay, that's good advice. Now, I also saw something about securing virtual machine parameters. What are those parameters and why are they important from a security perspective?
Those parameters control how the VM behaves and how it's configured. Some of them can have security implications if you're not careful.
Like what?
Well, for example, you can control whether a VM can connect to a CD-ROM drive or a floppy drive. You want to make sure those are deactivated if you're not using them.
Because someone could potentially exploit those features.
Exactly. It's all about locking down anything you don't need.
Makes sense. Now, what about logging and auditing? How does Cloud Foundation handle those, and why are they so important?
Logging and auditing are crucial for security and compliance.
Okay.
Cloud Foundation keeps detailed logs of everything that happens within your environment. And you can use those logs for a ton of things: troubleshooting, security analysis, compliance reporting.
So it's like having a security camera recording everything that's going on.
That's a great analogy. The logs give you a detailed record of everything so you can investigate security incidents, identify any suspicious behavior, and prove you're meeting those compliance requirements.
That's super valuable. Are there any best practices for managing these logs effectively?
Oh yeah, definitely. One key best practice is to centralize your logs.
Centralized.
Yeah, don't let them be scattered across all these different systems. Collect them all in a central location where you can easily analyze them, archive them.
So it's like having a central security office where all the footage from those security cameras gets sent?
Exactly. Centralized logs are much easier to manage.
That makes a lot of sense. Now, are there any tools within Cloud Foundation itself that can help me with log management?
Cloud Foundation integrates with VMware Area Operations for logs. It's a centralized platform. You can use it to collect, analyze, and manage logs from all sorts of sources, including your Cloud Foundation environment, of course.
So it's like having a dedicated team of security analysts sifting through all that footage.
That's a great way to put it. Area Operations for Logs has some really powerful tools. You can search, filter, correlate log data. It makes it much easier to spot those security threats and compliance violations.
That's awesome. Now let's talk about patching, which is another crucial part of security. How does Cloud Foundation handle patching, and what are some best practices to keep in mind?
Patching is essential, no doubt about it. You got to keep those vulnerabilities at bay. And Cloud Foundation makes it easy to patch both the management domain and the VI workload domains.
So it's not just about patching the ESXi hosts themselves. I need to patch the entire Cloud Foundation infrastructure.
You got it. The management domain, the VI workload domains, they all need to be patched regularly. It keeps things secure and stable.
Okay, makes sense. Any best practices for effective patching? Any tips you can share?
Always test your patches before you roll them out to production.
Oh, good point.
Yeah, set up a test environment, make sure everything works as expected. That way you can avoid any surprises in production. And set up a regular patching schedule. Don't let those patches pile up. Address them quickly to minimize your risk.
So it's all about being proactive and staying ahead of the bad guys.
Exactly. Patching is preventative security.
Okay, I'll definitely make sure to prioritize patching. Now, before we wrap up this deep dive, I wanted to touch on one more security topic: intrusion detection and prevention. Does Cloud Foundation have any built-in features for that?
Cloud Foundation itself doesn't have a dedicated intrusion detection and prevention system, or IDPS, but it works really well with NSX.
NSX, our trusty networking sidekick.
That's right. NSX has a feature called the Distributed Intrusion Detection and Prevention System, or DIDPS. It's like having a security guard that's constantly monitoring your network for any suspicious activity.
So it's watching for those intruders trying to sneak into my Cloud Foundation.
Exactly. DIDPS analyzes network traffic in real time, looking for patterns that might indicate an attack. And if it detects something fishy, it can take action to block or mitigate the threat.
That sounds pretty powerful. So it's not just about detecting intrusions, it can also prevent them.
You got it. It's a proactive security measure. And it's really effective at stopping those known attacks.
Okay, that's awesome. Now, we've covered so much ground in this deep dive, from the nuts and bolts of setting up your Cloud Foundation to managing and securing it, even those exciting AI capabilities.
It's been a wild ride.
It has. But before we officially wrap things up, I have one more question that's been bugging me. The documents mention VM encryption, but they also hint that it can have a big impact on performance and management. Can you shed some light on that?
You're absolutely right. VM encryption is powerful, but it's not without its trade-offs. It's like putting a vault around all your sensitive data. No one can access it without the key.
So even if someone manages to steal my virtual machine, they can't get to the data without the decryption key.
Exactly. It's a crucial layer of protection, especially with data breaches happening all the time these days. But you're right, it does come with some performance costs. Encrypting and decrypting all that data on the fly, it takes processing power.
So it's a trade-off between security and performance. Are there any ways to minimize that performance hit?
There are some things you can do. The encryption algorithm you choose, the type of workloads you're running, the hardware you're using, they all play a part. Newer encryption algorithms and faster hardware can help reduce the overhead.
So it's a balancing act, as always. What about the management side of things? Does encryption make things more complex?
It does add some complexity, yeah. You need to manage those encryption keys, make sure they're stored securely, handle key rotation.
That sounds like a lot to keep track of.
It can be. You got to plan carefully, choose the right solution for your needs. You want that security, but you don't want to create a management nightmare for yourself.
Okay, that's a great point. Now, we've talked about securing the infrastructure, managing those upgrades, even exploring the world of AI. Is there anything else we should touch on before we wrap up? Anything we've missed?
I think we've covered most of the bases. But one thing I would emphasize is the importance of designing for recoverability.
Recoverability.
Yeah, no system is perfect, right? Failures can happen. So you need to think about backups, disaster recovery, business continuity, all that good stuff.
Makes sense. But where do I even start? There are so many different options, it's a bit overwhelming.
Start by thinking about your business needs. What are your recovery time objectives, or RTOs? And your recovery point objectives, or RPOs?
Can you remind me what those are again?
Sure. Your RTO is how much downtime you can tolerate before it starts to really hurt your business. And your RPO is how much data you can afford to lose.
So if my RTO is 4 hours, I need to be able to get my critical systems and data back online within 4 hours of a disaster. And if my RPO is 1 hour, I can afford to lose up to 1 hour's worth of data.
Exactly. Once you know your RTOs and RPOs, you can start looking at different data protection solutions. Choose the ones that fit your needs and your budget.
Okay, that's a good starting point. But the materials we have here mention a whole bunch of different tools. Backups, replication, vSphere HA, Site Recovery Manager. How do I know which ones are right for me?
There's no one-size-fits-all answer. It depends on your requirements, your RTOs and RPOs, your budget, how much complexity you can handle.
So it's about finding the right balance.
Exactly. You want good protection, but you also want something that's affordable and manageable.
Makes sense. Now, before we officially sign off, there's one more thing I wanted to touch on. The materials really emphasize the importance of documentation.
Documentation is crucial. It's not just about creating a stack of papers. It's about capturing all those important details. Your design decisions, configuration settings, operational procedures.
So it's like a user manual for my cloud foundation.
That's a great way to put it. Good documentation helps everyone who's involved in managing and supporting your environment.
Okay, I'll make sure to prioritize documentation. Well, I think we've really gone deep on VMware Cloud Foundation in this deep dive. We've covered everything from the fundamentals to advanced features and best practices.
We've explored the architecture, the possibilities of stretching clusters, even dipped our toes into the world of AI workloads.
Listener, we hope you found this journey as enlightening as we did. Remember, knowledge is power. And with a solid understanding of VMware Cloud Foundation, you're well on your way to building a robust, secure, and flexible cloud platform, one that meets your organization's unique needs.
So go forth and conquer the cloud. And if you have any questions along the way, don't hesitate to reach out.
Happy cloud building.